I've shown you basically how to lay out the points for an NC program. If time permits, we'll get into that a little more later, and you'll get maybe some experience on how to do it yourselves. But basically you put your tool locations on a drawing of the part. You mark their XY coordinates, or XZ, YZ, whatever plane you're working in. You mark those coordinates, and those become the dots that you're eventually going to connect for connecting the dots. As you recall, the way we set up the program for the cribbage board is our origin is this lower left-hand corner. Then we created circles or tool locations at each one of these points around here as we go around the part, and then we come in, and then we'll go back and forth and so on, and create our tool path. But now we've laid out those points, how do we tell the machine how to go to those points and what to do when it gets there? The important thing to remember when you're laying out the points is that the only points you need are the points where something changes. Either the tool's changing direction, or it's going from rapid travel to a feed rate, or something similar to that. You only need the start and end point for any operation. So when you're laying out those points, it'll just be the start and end points. If our tool started here, we're going to come around here, it's going to start with a curve, with this arc that we talked about, and the arc is going to end here, so we need the start point and the end point of the arc, right? And then as we come down, we're going to go in a straight line. We don't need to know all these points in between. We just need to know the end point before we start our next arc. And so as we come around here, then this is the start point of the arc, this is the end point, and so on as we go on around the point. That's around the part. That's basically all you really do when you're laying out your points. Of course, you have to take into consideration the diameter of the tool, how far the diameter of the tool is from the cutting edge. You have to calculate where the center point of the tool is for each one of those things. When we've laid out those points, how do we tell the machine what to do? Well, that's with a programming language which is called the G-code language. I don't know why it's called the G-code language instead of some other alphabet letter, because all 26 letters of the English alphabet are actually used in G-code or NC programming. But probably because the G-code is the code that prepares the machine to do something. The G-codes tell the machine you're going to travel fast or you're going to travel at a feed rate. The G-codes tell which plane you're going to work on. For example, you could work on this plane, this plane, this plane, whatever. So G-codes prepare the machine and kind of give it the idea of what it's going to do, so to speak. And then all the other letters tell it specifically where and when and how to do it. M-codes are miscellaneous codes. And I mention them because it's often referred to as the G and M code. The M code are the miscellaneous codes, and miscellaneous codes turn things on and off. They may turn the spindle on and off, may turn the coolant on and off. M code can define spindle direction. M3 might be clockwise, M4 counterclockwise spindle direction. MOO, MO1, MO2, those are all commands that tell the program to stop. MOO is a program stop, MO1 is an optional stop, and so on like that. Another code that you're going to find is the F code that we'll be using in this particular program. The F code is the feed rate. So we may want to wrap it down to this part because we don't want to spend a lot of time moving through the air, slowly coming down to the part. We want to wrap it here, get as fast as we can, then we want to feed into the part to whatever our depth is going to be and begin making our cuts. So we'll use a G code to wrap it over to the part, then we'll go into a different, which would be the GOO. We'll use a different G code, the GO1, which is a feed rate enabled travel, linear motion, and we'll turn on the feed rate, and then we'll use the F code to tell it how fast we want to move. There's a couple ways we can do that in inches per minute, or if you're working with a lathe particularly, you'd use inches per revolution. But we'll be feeding in inches per minute, then we'll come around the part, and so on. So those are some of the basic commands we're going to be using this program. We're going to be using a different G code, which is, well, I'm not sure which one we'll use. We'll probably use the G83, which is a can cycle for peck drilling. So instead of just drilling the hole all the way and then coming out, we don't want to build up the heat on the tool, so we'll drill a little bit, we'll come out, clear the chip, go down a little farther, come out, clear the chip. And we'll do that with what's called the G83 code. Another code we'll be using will be the M98 and M99 codes. M98, of course, they're miscellaneous codes, but the M98 we'll call a subprogram, because we're going to create a subprogram to go around these little islands. But we're just going to create it for one island, then we're going to create that as a subprogram, then we're going to go around an island, we're going to go to a new location, we're going to call our subprogram, go around the island, and we're going to do that for, what was that, 12 times. Is that right? Yeah, 12 times, sorry. And then the same with drilling. We're only going to drill one of these. We'll write the code to drill one of these, and then we'll use a subprogram to move from here to here and start drilling all over again, and then we can go around the part. This saves us hundreds of lines of code, and it's also much easier to edit if we need to make a change and so on like that. So to make this part, we're going to use a GOO to rapid travel. We're going to use a GO1 to feed. We're also going to use a GO2, which is a, from your perspective, that would be, yeah, GO2 would be a clockwise motion going around the part. And we'll also use a GO3, which is a counterclockwise motion, which will go around the other way. We'll use M00 to end our program, or an M30 maybe, which is a program rewind. And it's just a handful of codes. The rest of it is all just going to be our X, Y, and Z coordinates. So let's take a look and see how we put those together.